Hello, hello. How's it going?
Pretty good. How about you?
I'm doing good. You know, the only thing that could make my life better and the fellowship experience is if people could just turn on their videos. Yeah, because we are working remotely and it feels very weird to talk to floating names. Okay. Um, Speakers will be joining soon. When you were giving the interviews, you might have also gotten asked a question, right? Uh, Regarding the audio and video stuff. This was the reason for that, because we wanted to see with whom we are working with. All right, Prithvi is here, I believe. Yep. Hey, Prithvi, how's it going?
Hi Kunal, it's been good. I think my co-speaker is here as well. It's Cyan Mondal.
Cyan
Yeah.
is here. Let me just add you as spotlight for everyone, and Cyan is here as well. I'm gonna add myself as well. All right, and the talk is recording. So welcome everyone to another nice session of the MLH Fellowship. And we hold these sessions because even though you're learning about production engineering, working on nice open source projects via these sessions, because we cannot cover everything in 12 weeks. So in order to get you started and give you a basic idea about what all things exist in the SRE, DevOps, and all these other, industries, we have such nice sessions. And first of all, thanks a lot, Prithvi and Sayan, for joining. And to everyone else, today we have a session on an introduction to cloud native chaos engineering. Now, this is not the first cloud native session in the fellowship. We had one on contribution to Kubernetes. We had one on serverless and all these other things. So thanks a lot for joining, Sayan and Prithvi. Before we get started, would you like to tell a bit more about yourself to the fellows?
Absolutely, absolutely. Thanks a lot, Kunal, first of all, for introducing us. And I hope I'm audible. I'm using just my earphones. So it's been a pleasure to join everyone. This is Prithvi Raj here. I work as a community manager for the Litmus CRs project. In the Kiosk native team, I've been part of the CNCF ecosystem since almost 1.5 years now. And I'm working on a lot of stuff. I think I'll go ahead more with the introduction once we start with the presentation. But yeah, it's great to see you all here, and I look forward to an amazing session with you all. Thank you.
Hi everyone, I'm Shayan. I've been a software engineer for Kiosk Native, and also I've been working on this project, LitmusChaos project, for over a year, and it's been great contributing. And I'm really excited to talk more about Kiosk engineering and how you can get more into the nitty-gritties of the same, and how you can just inject Kiosk with any basic setup. So it'll be pretty fun. Also, during the talk, if you hear any noise from my side, it's my pug at the background doing that. So yeah, great to be here.
All right. Well, thanks a lot for the intro. Maybe we can get started with the presentation now. And for everyone else, if you have any questions, feel free to send it in the chat, and you can also unmute yourself and ask it in the end.
All right, sure, awesome. So I'll be sharing my screen first, and then perhaps Sayan can take it forward. Just give me a second. Okay, is my screen visible to everyone?
Yep, I can see it.
Yep, make it too.
All right, awesome. So as you can see my screen, I mean it says Cloud Native Chaos Engineering for Hybrid Clouds, but it's basically introduction to Cloud Native Chaos Engineering itself. I'll start presenting. And moving on, before going ahead, I'll just talk a little bit about me, and then Sayan can just unmute himself and talk about himself. So, as I said, I work as a community manager for the Litmus Chaos project. The journey started back at Maya Data. So, in case any of you folks are aware of the project OpenEBS, or you are aware of basically what is happening in the cloud native data side, then Maya Data is doing a great job, and that is where Litmus came from. I mean, I'll before starting off with anything, just a very small history about the project. You'll be glad to know that this was an open source project that we just started writing to test. Like, this was an internal tool set, and we started writing it to test the main project. And then suddenly this became so huge. Chaos engineering was the scene. So we ended up making this a project itself out for the community, part of the CNCF ecosystem, and then it became a company altogether. So that's the power of open source. According to us, we believe that open source is the present, open source is the future. So it can turn out to be a project. CNCF is doing some amazing stuff out there by supporting these projects, by supporting, giving them platform. So obviously that is why it's so loved out there. And then obviously it's one more thing is that open source, when you start curating projects or when you start creating projects, you never know what's the future of it. So anyone who's watching this and is part of the cloud native ecosystem or the CNCF space basically, so I would urge you all to keep on contributing to it, and I hope this session helps you out uh, curate some sort of contributions. So other than that, I organize a lot of events. One of them is Kiosk Carnival, again a chaos engineering based annual conference. Kubernetes Community Days, if any one of you attended the one, the inaugural edition that we just hosted a few weeks ago, the Bangalore one, then worked there as well as a co-organizer. And then Kubernetes chaos engineering meetups happen every last Saturday of the month. So perhaps we'll be posting the links to all these sessions post the talk itself. So moving on, I think Sayan can just introduce himself and then we can get started.
Yeah, sure. Sure. Like I mentioned, I am a software engineer at Kiosk Native, and I've been working on this project for the past 1 year, uh, over 1 year. And I've seen a lot of ups and downs in this project too. So we started off from the very beginning, and then we sort of added more and more features. And I'm really proud of what Litmus is right now. And we are planning to do more with Litmus too. So with the Litmus 2.0, there's tons of features and uh, additional tools that we have introduced, and I'll also show them to you in this demo, probably a lot of them which are relevant to this particular introduction and are beginner friendly too. So yeah, that's mostly it, and I've had a great time at Kiosk Native and also at the Litmus project, doing all these contributions. So yeah, and you can also follow me on Twitter and LinkedIn if you want to stay connected with me regarding all these chaos engineering updates.
All right. So thank you, Sayan. Thanks for that introduction, and let's get started. So moving on, I mean, let's just talk about the agenda we have in hand. We'll be talking about chaos engineering first and why exactly chaos engineering is required. In case I heard that there's some introduction done, but we'll start from the basics and what are the issues that are persistent today in the ecosystem altogether, and then we'll slowly move on to cloud native chaos engineering and how different tools have come up in the market and what Litmus is and how you can contribute. And we'll have a hands-on, we'll run a hands-on chaos experiment as well, which will be pretty easy. So in case your systems are handy, so you can also run a little bit of chaos with us. So let's get started. Chaos engineering, I mean, see, a lot of people perceive chaos testing as various things. Some people confuse it with white box testing, black box testing, or part of the QA process itself. And what's the difference? Because being a part of the community, it's very important to understand the use cases that are out there. I mean, testing is important for a lot of folks, and with students out there, they kind of want to understand what exactly is the testing space all about, what exactly is happening, what will I do as a QA tester, or what exactly will I do if I go into cybersecurity or testing. But chaos engineering is something which is not your daily testing or not QA or penetration testing altogether. It's more of a technology which is crossed the adoption stage, or a lot of folks are doing it who have burned their hands. And it's all started with Netflix back in 2011. And how did Netflix get started with it? Just going back to the history a little bit. So Netflix, while they were understanding how to scale things, how to basically understand how they can prevent an outage if there's a spike in users. If, let's say, there's a series, a lot of people might have watched a lot of popular series that are out there. I mean, in India, it's Sacred Games, or in all over the world, Money Heist. So when there's a spike of users, when a new series or a new movie is out there, there's a possibility of an outage, right? The system can go down, you can see an error, or basically there needs to be a resolution in place, right? That is where chaos engineering first came into play, where it was just repeatedly, or it was just the process of testing an architecture or a computing system so that it can basically withstand unexpected or chaotic situations. That is how the chaos engineering name came into play, that you need to understand what if there is an abrupt situation, a downtime or an outage. So that is where the goal of chaos engineering was to identify the weaknesses that are in the system through a controlled manner. You cannot just go ahead testing anything and everything, but chaos tests need to be put down in a controlled way so that you can understand how the system will react in an unpredictable or a vulnerable situation. I'll take a very simple example. Let's say, as you can see, this is the mascot of the Litmus CHAOS project. So there's this mascot is organizing a few experiments. So in a Kubernetes application, just giving an example, what happens is there are a lot of, I mean, just it's not just the application, but there are a lot of layers, right? You understand, there's the Kubernetes application itself, and then there are other applications running alongside. There's the application layer, platform layer, MongoDB, so many things. And then other cloud native projects also are running alongside, let's say Prometheus, or Cert Manager, whatever you are aware of. So every system is vulnerable to an attack. Every system is basically there can be a possible outage happening in any sort of layer. So that is where chaos testing comes into play. Let's say in the Kubernetes layer itself, what will happen if a pod gets deleted? What will happen if a node is removed somehow due to some reason? So that is where chaos testing comes into play, where you test your systems in various stages. It can be either in staging, or it can be in production, or it can be while you're developing the system. But you have to, every persona has to run a chaos engineering test so that they basically understand what will happen if there's a disruption. So moving on, downtimes, as I said, it leads to a downtime. I don't know how many people are here from India, but in India there is a particular sale that happens every year that's called a Big Billion Day, organized by Flipkart. Or let's say there are a few sales organized by various platforms called Amazon, Myntra, and these platforms. And these sales usually have a spike in the number of users. There's a huge amount of users suddenly coming in. There's a requirement for curating payments and basically fulfill orders at a huge scale. And that is where a possibility of a downtime or an outage is. Or I'll take another example. Recently there's a huge boom in the crypto market, or there's a huge boom in the stock market. A lot of people are investing in cryptocurrencies, stocks. So for example, there was a huge downfall in the crypto prices a few days ago, and a lot of people were not able to actually sell their cryptos or buy new cryptocurrencies at that point of time, that particular point of time. Why? Because that particular platform, and I won't be naming any particular platform here, but that particular platform was not able to scale that amount of users, or the traffic that was out there. And that is where chaos testing had to come into play. That is where these particular companies or enterprises or any persona need to figure out that chaos testing will lead, if not avoided, or if chaos testing is not curated as a practice in the systems, then it'll lead to a huge outage cost. So as you can see, there are a few examples: $25 million for Apple and $150 million for Delta Airlines. I'm sure they are practicing chaos engineering right now. And then Facebook, I mean, $90 million. These are an example of few outages which have led to high operational costs and basically demanding repairs. So that is where the factor of downtimes come into play. moving ahead, as you know, if you might be introduced to DevOps or how DevOps functions in the software engineering space. So the DevOps loop gets activated when, basically kiosk testing is part of the DevOps culture itself. As you know, SREs and the DevOps persona are the one who brought in changes to this world with chaos engineering. And that is why it's not just us. If you talk about who are practicing chaos at a very high scale, who are the ones who are part of this development space, let's take an example of AWS. So Adrian Cockcroft, he is the VP of AWS, and he's you know doing some amazing stuff in the chaos engineering space, and he talks about the chaos first principle. So before the system moves into production, or before you move ahead deploying the system, or there's a release out there, you need to test that's the chaos first principle. Test, don't wait. You have to test the system first before it gives you an outage, and then you just regret not testing. So that's how chaos engineering functions. And it's more about, you test, you get the feedback, you understand if your systems are strong or not, you understand if your systems are basically functioning according to the desired results. And I'll move ahead to how basically the chaos engineering testing functions, or what are the principles. But all of it is part of the DevOps loop, where the eventual goal is to proactively test your systems in production. So moving ahead, what exactly chaos testing brings in, or who exactly it is for? I don't think it's just for enterprises here, although we are talking about enterprises because that's the eventual goal. But it's for everyone. If as a developer you're developing something, if as a developer you just want to, it's an open source project you're working on, that might be based on ML or AI itself. Even there, you need to have some sort of a chaos testing plan. And what exactly are the three priorities that are out there? Obviously, fallback. How does your failover plan work? There needs to be a failover plan in place. What happens? What will I do if my system fails? What will I do if my system goes down? And how safe is my business data? Consistency is key, right? You need to understand how safe you're putting out your data out there, and what if there's an outage or a downtime, then who gets to access my data? And then cost efficiency. There are a lot of testing plans out there, but why is chaos testing being adopted? That is because it's cost efficient. More because obviously there are cloud native projects out there, so you get to run a lot of chaos tests for free. So that's obviously efficiency. But even if you talk about the overall, the amount of money that is being spent out there in testing or software testing itself, chaos testing reduces that amount in a huge way. So let's say tomorrow, any one of you folks are working on the cybersecurity space, you need to pitch chaos testing to your manager or to anyone who's out there. Even for your projects, you need to pitch in chaos engineering. So there are 4 simple steps through which chaos testing is run. One of them is basically understanding the steady state of the system. You need to understand how does your system behave when it's steady. What exactly is the system like before an outage happens? And that is how it all starts, formulating a steady state hypothesis. So once you understand the steady state of the system, you create a hypothesis around it, that this is the steady state and this is how the system will behave if a chaos experiment is run, if a chaos test happens. So once the hypothesis is ready, you experiment. You run a few chaos tests. And let's say if one chaos test passes, if the chaos test is done, then obviously your system is resilient for that particular test. But if, let's say, the chaos experiment fails, there's a weakness that is found, then you need to fix that weakness, and then you adapt. That's how it functions, and it goes out in a loop. So there's feedback, and then there's again hypothesizing, and then running chaos tests. So these are 4 simple steps through which chaos engineering is done. We are not going into the complex mechanisms of it, but this is how, if you want to run a simple chaos experiment, you do it. So what are the principles? I mean, before we move on to cloud native chaos engineering, just talking a little bit about the principles of it. Obviously, it has to be open source. Open source is key, and community contributions are pretty important. I mean, there are various use cases that come into play. I'll give you a few examples. I mean, how chaos engineering is playing a part. It's being, it's been adopted by someone from the banking sector. It's being adopted by the fintech sector, automobile sector. So there are various use cases that come into play, which give rise to point number 4, that is community chaos. So chaos engineering is done in a collaborative way where every use case contributes to the project. Every use case contributes to the cloud native scenario, where you understand what are the different types of outages that can happen, what are the different types of chaos tests that can happen. Even you can write a chaos test. I'll give you a very simple example. There is one of the contributors in the Litmus Chaos project itself. He's just a final year student in college, and he has written a chaos experiment itself. So I don't think it's pretty harsh or hard for anyone to write a chaos experiment or be a part of the community. And that is where you contribute to the cloud native chaos engineering system itself. And then obviously, as you know, there are certain custom resources for Kubernetes itself. So there have to be certain APIs and custom resources for chaos engineering, so that you can manage your chaos tests, you can curate them responsibly, you can observe them, what is exactly happening, where is the system going down, where is the chaos test happening. So obviously chaos APIs and CRDs contribute to the chaos engineering framework. And then there has to be a plugin infrastructure where other sort of chaos, let's say there is something which is not there in the tool set itself or the ecosystem itself, then other chaos libraries should fit into the framework. The framework should not be, you know, just restricting the user to conduct a certain amount of chaos tests, but everyone should come in and curate any type of chaos tests, write their chaos engineering experiments for themselves, making it basically part of the plugin infrastructure. So how is it done typically? I think, I mean, as of now, and there's, I hope a lot of people know about the SRE persona or what exactly SREs are. So SREs have focused on chaos engineering explicitly, but developers who are who are part of the change, who are coming in, are also practicing chaos in some way or the other. And obviously it's rarely integrated into the CI/CD of the system, but as I mentioned, chaos engineering can be done anywhere. It can be done to the CI/CD, DevOps pipeline, or staging, production, any normal random test. So as of now, the situation has not been pretty good. I honestly, I mean, there is adoption, but there needs to be automation. That is what is necessary. There's manual planning, but chaos engineering has to be automated. You don't want to run your experiments just by typing or bringing in a YAML file and coding it out and running one test and then making it a very tacky sort of process. And there are chaos engineering game days. I think that's the most important part of it. A game day is where you run various chaos tests specific to your application, and they usually happen in a production like system, but you can do it in a staging environment as well to understand what are the vulnerabilities, how does the toolkit function, and which chaos tests basically fit into your application. So, I mean, why Kubernetes? I think a lot of people obviously are well versed with Kubernetes, what Kubernetes is, so I won't be defining. It was found by Google, and now it's maintained by this Cloud Native Computing Foundation, CNCF, as I mentioned. And there are a lot of things that Kubernetes has, and you can contribute. I hope you must be contributing to Kubernetes as well. But chaos engineering for Kubernetes gets more popularity due to the idea of Kubernetes adoption, that Kubernetes is being adopted by everyone. Kubernetes is the future. If I give you examples of e-commerce platforms in India, which are coming up in a huge way, which many of you might be knowing it itself, they are shifting to Kubernetes, and all around the world they are shifting to Kubernetes, from legacy systems, from monolithic architectures. Everyone wants Kubernetes workloads today, and that is where vulnerabilities come into play, and Kubernetes needs chaos engineering. Kubernetes and chaos engineering have to go hand in hand. So, I mean, this is something which was put down by CNCF, that what are the challenges what are the budding challenges in the container space, or what challenges exactly are containerized workloads facing according to a survey. And as you can see, all the challenges that are put out here: complexity, cultural changes, security, storage, lack of training, monitoring, these all have a correlation with chaos engineering in some way or the other. I'll be emphasizing on complexity, cultural changes, security, of course, and reliability mainly, and finding vendor support. But that's not what we are going to talk about here. So these are the major container challenges which chaos engineering caters to. So complexity, your systems are complex, they need to be eased out, they need to be scalable. So chaos engineering must be in place. Cultural changes, people are reluctant to come out, do some chaos engineering out there. So the cultural changes need to be put out there. I'll give you an example of Disney. They were pretty reluctant. What is this chaos testing, man? I don't understand this. How does it help me? So it takes time for you to understand that this is priority and put it out in the roadmap, because there isn't a lot of expenditure that is put out there for chaos engineering, and which needs to come into play. And then there's security aspects and reliability. Security and reliability go hand in hand. So chaos engineering basically helps you cater to such challenges, to basically understand that, where or what sort of reliability requirements need to become coming into place, and how your systems can be very, very strong. Chaos testing, I must tell you that people, in spite of having so many testing principles into play, are still adopting chaos testing because of these challenges, because how these challenges portray the overall containerization future. So for Docker containers, any container you're using, and Kubernetes itself, reliability is a budding challenge, and that needs to be catered to. And lastly, Kubernetes, as we mentioned, cloud native space, so Kubernetes is a part of it. So it needs a resilient tool set. So traditional chaos engineering tool sets are out there. There's Chaos Monkey, invented by Netflix, and there are a lot of paid services which I don't think as students you all are going to use. As students, you don't want to pay tons of money and run a chaos test or contribute to it. But it doesn't suit the cloud native persona. Then we are talking about cloud native people, it doesn't suit. And CNCF had used to have SIGs, now it's tags. So from the SIG to tag, there was a shift in, emphasizing on chaos engineering and GitOps. I'm not sure how many people of you are very well versed with GitOps. But chaos engineering, operations, GitOps, these continuous verification, and SLOs. If any one of you pursue or want to be an SRE in the future, then SLAs, SLOs, and SLIs, software level agreements, software level objectives, and uh, I mean, software level indicators. These are very important for CI/CD functionalities, and you will be getting well versed with what exactly are these factors and how chaos engineering play a huge role there. So with this, I'll perhaps give the control to Cyan, who'll talk more about cloud native chaos engineering and introduce Litmus to you. But before that, if I have any questions, if there are any questions for me, please feel free to drop them. So I can see a couple of things in chat. Yeah, you can take a look at the slides. We have put out the slides on the GitHub itself, resources section. And feel free to check the repo. There are a lot of resources. I'll be posting more and more resources while the talk goes on. But if you want to contribute, eventually the goal is to get students to contribute. We want everyone out here who's watching this talk or who watches this talk in the future to contribute to the ecosystem, to understand what chaos testing is and take it forward. So check out the slide deck here, and then I'll be posting resources. So do we have any questions?
If you have any questions, feel free to let us know in the chat, or you can also unmute yourself and ask.
Sure. So
Any
I'll
particular
perhaps.
question, yeah. Even does not matter how basic it is, it's totally fine. I know you all already have learned about like Kubernetes and stuff. So any questions you may have.
Okay, perhaps I think science presentation might bring up a few questions. So I'll stop sharing my screen, and I hope as of now it's been a good journey. Feel free to post them in chat. So Sayan, it's all yours.
Okay, great. Share my screen. Good. See it?
Yeah. It's visible.
Awesome. Awesome. So thanks, Prithvi, for mentioning all the different challenges and the reason why we need chaos engineering. Now, moving on to cloud native. What actually is cloud native? Why we need a cloud native chaos engineering approach? I'll be talking about that, and I'll also show you the different projects that are out there that are actually doing things that we are also doing, and what it's lacking, or what are the areas in where we sort of stand out, or what are the benefits of using Litmus. So to start off with, what is cloud native? Basically, it's all the good side of a basic cloud computing application. So cloud native is an idea, is an approach where you take all the best practices of cloud computing and you use it to build, run, and scale applications as you go. So with this cloud native approach, you are making more and more dynamic applications, more modern applications which are dynamic, and you can use these cloud native approach, this cloud native entire architecture in your private, public, as well as both hybrid clouds. So that's basically how cloud native came into the picture. And then, like Prithvi already mentioned, the principles of chaos engineering. Here are the principles of cloud native chaos engineering that we believe to be very important, which are like four of them you have already seen in the previous slide, but an additional one is GitOps. So like Prithvi mentioned, it's always a good idea to make your like to have open source as one of the principles of chaos engineering and cloud native chaos engineering especially, and with that comes community collaboration, since the more and more people adopt it, the more community contributions we get. It we individually, the entire project grows as a platform and as a project. And also there's something called as observability, which is basically a measure or way of monitoring your system, what's happening in your system in a live setup, in a real life monitoring, let's say. So it has to be open. What I mean by that is, let's say you have your own solutions, or you have some other tool or tool set that you want to use as observability, and you can easily integrate that in any of the platform or any project that you're using. And also open API and lifecycle management, which is basically any APIs or any lifecycle management technique that you're using. It should be open. It should be free for everyone to use. Like any other project, if they want, they can take out your APIs. If any other APIs that are important to you can fit in your particular use case. So it should be flexible, and that is what it means. And then there's also GitOps, which is basically Git as a DB. Like you've heard of DevOps, but GitOps is basically an ops approach where you use GitHub as your DB. Sort of what I mean by that is you get full version control as well as um, task level versioning control. Let's say some member of your team is doing something and they're pushing the events in GitHub, then you can go back and track the history of who pushed what is used by whom, and basically Git will act as your database, and then you can also see and track everything who is doing what. So that helps in tracking and management. So yeah, that's brief about GitOps, and these are the 5 principles that we believe are very important to be a part of CNCE. Now, the major benefits of cloud native chaos engineering are you can run services without any outage, since you would already test out your services for any outage, for any breakages with chaos engineering in your cloud native space. You can run services to meet the business SLAs and SLOs. So I already mentioned Prithvi mentioned the SLAs and SLOs. But to brief it up, then you can think of it as think of an SLO as like the metrics or the performance metrics that you are promising someone. So let's say you are promising person A that I would provide this in this much speed in this much time and something metric. So that would be your service level objective. That is an agreement that you're doing to them. So you need to meet those agreements that you're making, and cloud native chaos engineering would help you do that. That's a major benefit of that. And then you can also scale your services on demand, and so you can raise your number of replica sets, so you can scale as you want. And with this layer of chaos engineering, you would always be protected since you are already safe, since you have already tested it. So no matter how much you scale, you would always have a like a layer that's protecting you. And you can obviously upgrade your services without any outage because of this layer that I just mentioned. Now, these are the different tools that are out there which are sort of doing it in a similar way. And these are great tools. You can go ahead and try them. But a few cons, a few disadvantages that we found in these projects, which were like some of the projects were pretty good, pretty amazing, but they had some sort of a language barrier, or the market was pretty scoped to certain areas only. But and a few other projects, the dashboard wasn't very secure. It had some sort of a security flaw. And in other projects which are very good and didn't lack any of these, but they had no native support for scheduling, so you had to schedule individual experiments manually, and that was pretty hectic. So we decided to incorporate all these different changes and make things much easier for everyone out there. So with Litmus, what we planned to do was follow all these 5 principles of CNC that I just mentioned. And Litmus actually has all of these 5 principles inside of its control plane. And to just talk about what Litmus is and how you can get started with it, Litmus is basically a cross-cloud control plane for your Kiosk native Kiosk engineering use cases. What I mean by that is, let's just break things down here. Like what I mean by cross cloud is you can have your applications deployed in multiple cloud providers, and you can have Litmus installed anywhere in any one of them, or you can just even connect Litmus to any other clusters too, running in any other providers. And you can inject Kiosk in any of those providers. So let's say you are using Litmus in AWS and your application is in GKE. You can inject Kiosk in GKE, although your portal is in the control plane is in AWS. So yeah, you can do all sort of things, and it's basically a hybrid cloud approach. And what I mean by control plane is the central most heart of our project, which is where everything that the Kiosk orchestration and everything that happens around Litmus happens from the control plane. And of course, it is cloud native, so you can target your individual microservices with this Kiosk engineering approach. So that's more about Litmus. And previously, we, like Prithvi was mentioning, that this was mostly an SRE personas like these, and we also shifted the idea of making it more for the SREs to making it more for everyone. So like students, developers, general developers who are just like, let's say you're developing your library application or just trying out anything very basic and you're putting it up on a cloud service, then you can of course do Kiosk engineering on against that. That is totally doable. And also with the idea was to move it mostly to the ops side of things, not just like scope it to SREs. So it would be both for dev as well as for ops with this new approach. Now, typically, how would you install Litmus and how would you use it? So there's Kubernetes manifest already present out there for you to install a Litmus, which is pretty simple. You can just apply the manifest and it will be installed. Also, there's Helm charts available, so you can like use the particular Helm chart of Litmus, and then you can pull that Helm chart and like download the Helm chart and use that Helm chart. And of course, there's a concept of Kiosk Hub, which I'll just talk about in a bit. So if you not know what is Helm charts are like simple packages of multiple Kubernetes, like multiple Kubernetes packages combined into a single file. So that's what Helm charts are, and they call it chart. So you just pick one particular chart which has multiple of these individual YAMLs, individual manifests. So they combine, and you can install from one single source of truth, and they'll install all the other dependencies or dependent YAMLs. And what is Kiosk Hub? Kiosk Hub is basically the host hub, the hub of different multiple experiments that we have. And these experiments that I talk about, there's a variety of them. So you can get pod level, node level, other cloud provider level, VM level, and all these different kind of experiments. And you can combine these different experiments to form a workflow. So yeah, that is what is Kiosk Hub. And these are the different scopes of the experiments. You have pod Kiosk, node level Kiosk, network level, stress level, cloud, and application level. So in application level, you can also target Cassandra or Kafka or let's say OpenAPS. And if you have your specific application in mind, you can write your own custom Kiosk workflows or custom, you can write your own custom Kiosk workflows to inject Kiosk for your specific needs. Now just let me just come out of this a bit, and just need to search hub.litmuschhaos.io. So this is the public URL of the Kiosk Hub that I was talking about. And here you can find all these different lists of experiments that are there. So you have generic experiments which are like pod delete or notate and these things, and you have application level experiments, VMware experiment, Cassandra, OpenEBS, and you can explore it. And we have 53 experiments as of now and counting. So you can of course explore it and find the different experiments that suits your requirement. So coming back to this architectural diagram, so this is what I would say a base architecture diagram for Litmus to inject chaos on any non-Kubernetes entity. What I mean by that is, let's say AWS, Google Cloud, Azure, or VMware. So these are non-Kubernetes entity. So you can inject cloud in services that are running on those providers as well. But your the control plane has to be installed on a Kubernetes, inside of Kubernetes. It has to be in Kubernetes. So the major CRs that I want to talk about here are the Kiosk operator, which is like the heart of the project of the control plane, which is like which controls everything. So let's say you want to inject a pod delete experiment in some of your, you want to delete a pod by injecting a pod delete experiment, Kiosk experiment in one of your application, then Kiosk operator would be the one that's responsible to identify that whether you want to do a pod delete on Nginx. So if Nginx is present or not, whether you want to delete that in a separate cluster, so if that cluster is there or not. So those validations and policy checks, those important things would be controlled and maintained by Kiosk operator. And also there's another CR called Kiosk engine, which is actually the pod delete that I just mentioned, right? So the pod delete is a Kiosk experiment, which is another CR. The Kiosk experiment CR is pod delete. Kiosk engine would bind that Kiosk experiment to your application instance. So Kiosk engine would bind your pod delete to Nginx. Let's say we are taking example of Nginx here, and Kiosk operator would actually try to look for if Nginx is actually there, if there's a cluster who's running Nginx, and whether what you're doing is correct or not, and those validations. So yeah, that's basically Litmus in a brief statement. So let's just actually see everything in action. And I would just want everyone to, if they can, to go to this particular link, which would be a very simple walkthrough of Litmus. I'll just paste it in the chat, or maybe Prithvi can share the same. I'll just go ahead with the demo. So Prithvi can post this particular Litmus bot scenario in the chat, and this is just a caracoda scenario which will explain chaos injection on an Nginx pod, on an Nginx deployment that would be running. So let me just go ahead and start the scenario, and if you want, I would really appreciate if you can just follow along. So this will give you a very good idea of chaos injection, and you can do this right in the cloud platform, which is like hosted there for you, so you not have to run anything on your own on your local machine. And also this is just a click and play type of scenario, which is where everything is already there for you. Just have to click on it and it will be executed. So the idea here is we want to first deploy the application that we want to run chaos on. So in this case, Nginx. Let me just see if it is actually mounted. So if it is there, cool. So I want to deploy Nginx, and as you can see, Nginx was created in my cloud setup. And if I just check the label, so there's this app equal to Nginx label which we want to target to do chaos, to execute chaos on. Now, if I just continue, there's this option of applying the LitmusChaos operator. Now, why we require this is basically with the help of the operator, we would get all these different CRs that are there, like we'll install Litmus, we'll have the service accounts, the role bindings, and those things which are required for Litmus to execute chaos. And if I just apply this, it will install all these different CRs, the dependent CRs that we require. And also, if I check the namespace now, we'll see that there's a Litmus namespace that was created just 5 seconds ago. And this is the Litmus, this is the namespace where all our CRs and all our dependent services were created. So if I just do kubectl get pods -n Litmus, and you can see all the resources that are running. So there's this chaos operator CE, which is running there. And that is the operator manifest that we just installed. So if we just move forward and check the CRDs. So if we just grep for the CRDs, then we'll see that these are the 3 major CRDs that I also mentioned in the presentation. So there's Kiosk engine, there's Kiosk experiment, and there's also Kiosk result. Now I didn't mention about Kiosk result. Result is one of the CR which actually pulls out the result of the Kiosk workflow that actually happened. When, let's say, when your entire Kiosk injection finished, then you can check the result of that particular Kiosk injection with the help of this CR. So it will give you things like the verdict of the experiment, whether the experiment failed, or what was the resilient score, what was the percentage of the resilient score, and those things. So these are the three important CRs that are there. So that already got installed when we installed the operator. And now if we move forward, there's this step of installing the Kiosk experiment. So you can install the Kiosk experiment from a list of all this experiment. For this one, we'll be selecting pod delete. As you can see in this command, we already have generic /pod delete /experiment YAML. So if I apply this, the experiment would be pulled in my system. Now note that this would just be pulled or downloaded in my system, and it will not be executed. So it will only be executed when I trigger the Kiosk engine, not the Kiosk experiment. Kiosk experiment is just like a blueprint of the experiment that are there. So if I just get the Kiosk experiment with this command, kubectl get Kiosk experiment, I'll see pod delete is there, and its age is 17 seconds because it was downloaded 17 seconds ago. Oh, there's my bug again. So if I move forward, I can apply the RBAC. RBAC is needed to like bind the different roles. So it's a role binding basically, which is required to create the service accounts and all those things to bind our application, the experiment with our application. This is just like a formality in order for everything to be compact and bound together. You can also annotate your applications to like control the blast radius, but that's like an advanced topic. And also, if I do a kubectl get pod, now this is just a check. What is it checking? It's actually checking if Nginx is there. Nginx is running on my system, and it is running. It's running from 3 minutes 4 seconds. Now I'll just apply this Kiosk engine. If you see in the statement says applying the Kiosk engine manifest to trigger the experiment. Now as I apply this, my Kiosk injection will be triggered on this Nginx application that was running. So if I just watch for this command, I would see that there's a Kiosk Runner. So the basic flow is Kiosk operator creates a Kiosk Runner, and the Kiosk Runner creates multiple Kiosk jobs. What I mean by jobs is pod delete here is a job. If I had done a separate Kiosk experiment, let's say container kill would be a job. So all these jobs are responsible for killing your container or doing Kiosk on your particular application. And Kiosk Runner is responsible for spawning all these jobs. This is like a multiple hierarchy, but you do not need to go in that much depth. The basic idea is pod delete is running, and it is trying to kill this Nginx container. So as you can see, it's terminating, and then it's again like it's Kubernetes, right? So Kubernetes would not let your application die. It will try to auto create another application when one terminates. So that's what's happening. Our Kiosk injection is actually happening, and it's killing the container. It's killing the pod, but Kubernetes is actually not letting it die and recreating or respawning another Nginx container. So with this approach, we get the idea that our particular Nginx application is pretty stable because we deleted a pod, but our Kubernetes did not let the Kiosk injection disrupt our system, and Nginx, how it was, the steady state, it came back to the steady state. So our hypothesis here was to inject a pod delete on the Nginx container, and Nginx adapted to our system and it came back to the steady state. So that completed the entire Kiosk engineering life cycle that was mentioned in the previous slide too. And now we see both of them are completed, and Nginx is still running. It's running for 46 seconds, but previously it was 3 minutes something seconds. So if I close this watch statement and continue, and this is option of Kiosk Result, which I mentioned at the start of this demo. So if I just describe the Kiosk Result, I can see the events that are there. And one of the events, previously it was awaited. If you can see the time, it's 90 seconds. It was awaited, but 40 seconds just recently it passed. So our Kiosk injection actually passed. So yeah, that's it. That's how you did Kiosk. And this was the core method of doing Kiosk with Litmus. Now coming on to the new Litmus, which is this, which looks much cooler, by the way. So we have all these manifests, like the CRs installed. I already have them installed in my system, and these are the ones. So I just applied a simple kubectl apply -f and then the CR, the manifest link. You can also do a Helm install, like I mentioned, and you will find all this information in the Litmus repo itself. So if you go to the Litmus portal folder in the readme, you will find all these different details. And what I also have is I have a namespace called my app. So if I do a kubectl get ns, I'll see this my app namespace, and my app is actually running. Just a minute. My app. It's running an Nginx container, Nginx deployment. So we'll try to do the same thing that we did with Katacoda in that. Cloud Shell, but in the new version of Litmus, we'll be doing it all automated and all through the UI, and you would see the entire Kiosk injection happening live. So this makes it much easier for developers, for anyone starting out, also for enterprise people. So these are the different CRs that are running right now, which is the Litmus portal front end, the server, and the Mongo. So we are using Mongo as a data storage, and these are the other dependent CRs that we require. So there's Kiosk Exporter, the operator that I just mentioned, being the heart of the operations that happens. And there's also Event Tracker, which we use for GitOps. So moving on, if I just select workflows and I schedule a workflow from this option, then I get to choose this agent. So what is an agent? An agent, let me just go to the agent real quick. So as an agent is basically where you have installed Litmus, let's say AWS. So AWS is your self agent. In that case, you have installed AWS in a specific cluster, then that cluster is your self agent. So wherever you install Litmus, Litmus considers that to be the default location of Kiosk injection. So it will already create that particular cluster as a self agent. So you'll already have that agent, that cluster with you. So in case you want to do any sort of injection, let's say in this case Kiosk Nginx pod delete or something, Nginx container kill or something, then we know that Nginx is deployed in this particular cluster itself. It's just in a different namespace, but it's still the same cluster. So in case you want to change clusters inside of AWS, or let's say you go to some other place, you install Litmus in Azure, and you create a cluster on GKE, then those clusters you can also connect as external clusters, and those external clusters can also be a part of this agent list. So then from this wizard, you can choose which agent you want to target. What I mean by that is, in this case, I'm targeting self agent, which is this Minikube instance that I have here. If it was Azure, your Nginx was running in Azure, then, and this was running in GKE, then you can connect Azure to your portal, and then your Nginx container running on Azure, you can choose the agent as Azure. Then that would mean your target application that you want to inject Kiosk on, you would choose that particular agent. I hope that makes things clear. So I do not have much installed like connected right now, because this is just a simple demo. And you have 4 different options. You can import your own YAML if you have some. You can create a custom experiment. You can choose from a list of predefined ones. So we have Potato Head and Softshop. These are like the de facto standard Kiosk engineering predefined templates, you can call it that. And also if you have, let's say, requirement of creating your own custom experiments, your own custom workflows, and reusing them again and again, you can save them as a template, and you can use your own templates. So these are like de facto templates that are there in CNCF, and these are like your own custom templates that you've created to make things faster. So I'll just select the normal Kiosk Hub. Oh, and I also forgot to mention this one simple detail, which is charts. So this is Kiosk Hub, which is the same thing, Kiosk Hub, the hub of all these different experiments, a list of all these experiments. Now, what is this? I also have a demo chart. What I mean by that is I have my own requirement of my own experiments. So I have created this repo, and this is a private repo. I can, with Litmus, I can connect that repo, that individual list of experiments, to my portal, to my control plane, and I can use those private experiments as well to inject Kiosk. So it doesn't have to be the experiments that we provide you by default. You can connect and create your own experiments, own workflows. It all depends on you. So as you can see, it's 24 experiments. This is my private one, and this has 52, which is the same as this. So let me just go back to workflow, select self agent again. And I want to do a custom pod delete, the same experiment that I did on the provider. I just want to do a pod delete. I just name this, let's say, pod delete Nginx. And okay, so this is where you see a visualization towards the left of what exactly is there. So I currently have an installed Kiosk experiment, which is already bootstrapped. So if you click on edit YAML, you will see the YAML, but I'll show this to you at the end. But I'll just select the generic pod delete experiment. And what I want to do here is do a pod delete on my Nginx application running on a different namespace. So as you can see in this table, I have name pod delete experiment namespace default, which is wrong. I do not have it in the default namespace. I have it in my app namespace. So I just changed the namespace to my app, and you can see the list of namespaces are already there for you. So you can choose from this list, and everything looks fine. I just go next, next, and finish. So these are like extra tunables, which are advanced settings. And now you can see that the bootstrapped version has the install kiosk experiment and the pod delete attached with it. Then we also have reverse schedule. What it means is, let's say your kiosk injection completed, it will obviously leave a lot of resources back, right? So if is this still running? Yeah, okay, so I can show you that. If we do a watch previously that was there, then you can see the Nginx Kiosk Runner and the pod delete were completed, right? But they're still running, they're still there, not running, they're completed, but the resources are still there. So with this approach, what we wanted to do was we wanted to gracefully clean all the kiosk resources that are left behind after the kiosk injection is finished. So that way you have your kiosk requirement fulfilled as well as your setup cleaned as well. But if you do not want to do that, you can of course choose it false, and like you can use your own analytics setup if you want to take those metrics out, keep those metrics somewhere. But yeah, that's the point of it. So if I go next and schedule it now, this is a summary of what I'm trying to do, cluster, which cluster I'm targeting this against, what is my description, name of the workflow, what is my like the scheduling, like if I'm doing a cron schedule or if I'm doing a normal schedule, and what experiment am I running and everything. So if I just view the YAML, I can see everything was generated from the get-go, and I did not type anything, but I just specified which application is where and what experiment I want to do, what kiosk injection I want to do, and it just created an entire workflow for me with all these different parameters like total kiosk duration, what is the total kiosk duration, what is the interval, what is my target pod, and everything. So if I just finish, then I should have my experiment, the workflow running. And let me just go to, now you can see the pod delete Nginx is starting to create. Now if I just do a watch, I'll get pods of the my app, we can see the same behavior, which is it's running from 130 minutes, right? So what we will see is this would start terminating, and when this will start terminating is the same behavior. It's all on Kubernetes, so Kubernetes won't let it die. It'll recreate another pod, and then this thing will keep on happening. But let's say this was some other application, your own custom application. So if something broke, you can see the logs, you can also check the kiosk results to see what exactly happened, and you can find out what was the issue. So that is really helpful. So if I come back here, you can see the pod delete Nginx is not ready, and this is starting to do something. Pod delete Nginx container is spawning, it's an init container. So if I go inside of this, I'll see a visualization of what exactly is happening, which will make things much clearer for me. And now you can see this is the main workflow, which completed the install kiosk experiment step. And if I click on pod delete, I can see the live logs of what is happening. And I see the pod delete experiment is currently being injected. And if I come here, this should, yeah, okay. So the old one was terminated and the new one just started creating itself.
I guess I got disconnected.
I got disconnected. Yeah.
That's completely all right.
That's fine. Do we have any questions? I know that was a lot to take in.
I'm sure that was, I mean, I hope that folks understood a few of it. I'm not sure if folks were
It's fine.
well.
It's fine if you did not get like entire thing. But a basic idea about, if at least you got a basic idea about what is chaos engineering, that's more than enough. That's great. So any questions related to that? Sayan is here.
Yeah, I guess there was too much load on my system. I'm so sorry. That's chaos in real life. Okay.
That's all right, Sam. That's completely all right.
I think, yeah, it's still working. That's fine. Okay, so that was the point. It's 61 seconds and running. So you saw the live chaos along with me. So yeah, that was the end of it actually. That was how you can do chaos with the portal. And post this workflow finishes, you can also check the results. It won't come out now since it's still in progress, but once it is completed, you can check the result, which will give you the experiment verdict and what happened, and what is the resilience score and everything. So yeah, that's mostly it. All right, that finished as well, so I can show you the results too. Okay, so if I just scroll down, you can see probe success percent 100, phase is passed and verdict is passed. So it's the same verdict that we saw here. verdict is passed and probe success percent and fail. So the experiment status, the metadata is the same. So yeah, that's how you do inject kiosks using Litmus control plane. And also you see an overall resilience score of 100%. Everything was pretty great, and we had 1 out of 1 experiment which passed. So yeah, that's how you do chaos injection with the portal. So if there are any questions, I'd be more than happy to take them.
You have any questions?
All right, folks. I think it was a lot of information to take for you, but I think I'll move back to the student community and how folks can contribute. So the idea here is that you can contribute in the code base itself, or you can do non-coding contributions as well. So what I'll recommend is, because it was obviously we had 1 hour and we cannot go through everything. So what I'll recommend is you can just get started watching YouTube videos. I'll post the link to the channel here, so you can just watch the introductory videos, how students are focusing on it and how students can contribute. And the second thing is I have posted the link to join the Slack community and also the resources section. So I think both of them will be very helpful for you to understand what exactly is happening in the community and what resources are important for you to get started. There are a lot of students who are part of the community, so they are already contributing in some way or the other. What I'll recommend is you just go through the documentation, through the videos, and once you're done with that, you can actually come and write a blog. A simple blog will help you understand what exactly chaos engineering or cloud native chaos engineering is, and maybe run a few tests. There's this link which is not in basically in production, or I would say live yet, but this has a lot of information. This beta.netlify link, which is supposed to go live by the time next month comes in, that will give you a lot of information. So I'll welcome you all there, and then we can get started. We can have more sessions, or have a one-to-one questionnaire or something, and that will help you contribute. You can contribute a lot of stuff, just translations, non-coding contributions, documentation, even a simple bug fix. There can be a lot that you can contribute to. So that's it, folks. Thanks. Hope you all enjoyed the session, or it was informative to you.
Most definitely. It's going to be recorded and I'll upload it on YouTube later on. But thanks a lot, Sayan and Prithvi, for joining. Really appreciate it. And thanks a lot for the nice demo, Sayan. That was great. And yeah, in order to get involved, all the links have been shared in the chat, so you can join the Slack channel and stuff. And yeah, that was pretty much about this session. And thanks for joining, everyone. We'll see you in the next one. Thanks again, Prithvi and Sayan, for joining.
Thank you.
Thanks a lot, Kunal. Thanks a
Bye.
lot, everyone. Bye.